Hello, I'm Lauren Ponisio, and I'm going to tell you a bit about research we've done comparing the yields of organic and conventional agriculture practices. So it may not be news to many of you, but agriculture today is fundamentally unsustainable. For example, we are eroding lands far faster than soil can be regenerated, and we are already using 70% of freshwater resources for agriculture. These issues will limit agriculture production in the future. In addition to being fundamentally unsustainable, agriculture also causes many environmental problems. For example, agriculture is the sole largest contributor of greenhouse gas emissions. These emissions are largely from sources like tropical deforestation, livestock, and just fertilized soils. Agriculture is also a leading driver of biodiversity loss. So in the map in the red, those are biodiversity hotspots. And right now, where most of the land is being converted are those biodiversity hotspots like Indonesia. And this is causing enormous impacts of biodiversity as these lands are converted to industrialized agriculture, like, for example, oil palm plantations, as well as livestock feed, biofuels, and oils. And agriculture already covers 40% of the terrestrial land areas, so this is only going to get worse. If that weren't enough, agriculture is not fulfilling its ultimate purpose, which is feeding people. So there's already, 1 billion hungry, 1 billion overweight. This number fluctuates somewhat, but in general, people are not getting nourished. And if that weren't enough, we throw away 30 to 40% of the food we produce. So it's pretty easy to see that the way we grow food today, or industrialized agriculture, is not feeding the world. But what can? To achieve environmental sustainability, we must grow in a manner that protects, uses, and regenerates ecosystem services instead of replacing them with all of these industrial inputs that are causing so many environmental harms. Enter diversified agriculture. A diversified farming system maintains critical biodiversity that promotes key ecosystem services. And it does so by mimicking nature. So, for example, this is Full Belly Farm up in Northern California. And this is the Carrizo Plain in Southern California. So maybe this is something like what the Central Valley used to look like. So you can kind of see the similarities. So, and all of this diversification is achieved through a suite of farming practices operating at different spatial and temporal scales, from a single plot to a field to a landscape. For example, at a plot scale, a grower may choose to implement polyculture or intercropping. These techniques are intended to spatially diversify the farm through planting multiple crops at the same time. And all of that diversity above ground supports below ground diversity, promoting soil fertility and water retention. So polycultures are supporting important inputs, such as agriculture inputs, such as nutrients, water, and soil. Spatial diversification also promotes ecosystem services providers like pollinators and natural enemies. And so these are attracted to that above ground diversity. And this reduces the concentration of specialist pests, as well as reducing the need for imported pollination. So these practices are also supporting these ecosystem service providers like pest control and pollination. All of this reduces the need for external inputs like pesticides, fertilizers, and managed pollinators, which are associated with many of the social and environmental problems caused by agriculture. Another technique that farmers might choose to implement at a slightly larger scale is crop rotation. So crop rotations are promoting instead temporal diversification. Crops are planted in the same area and are changed either between years or within a season. Crop rotations are also known to support a suite of these different agricultural inputs and services, much like polycultures. Other techniques at larger scales can also be implemented. For example, hedgerows and buffer strips, riparian corridors and meadows, and even enhancing or restoring natural areas. So because of all of these increased agricultural inputs and ecosystem services, this greatly reduces the need for these external inputs. So then why are they not more widely practiced? And the argument that comes up over and over again is that alternative, more sustainable forms of agriculture are somehow fundamentally lower yielding than intensive conventional agriculture, such that the expansion of these techniques would lead to extensification of agriculture, so increasing, using more land area, possibly causing further harm to biodiversity in the environment. And just to reiterate, we produce more calories than we need, and increasing or maintaining yields would not actually ensure our food system would feed people. But at the same time, small-scale farmers are the majority of farmers and the majority of people who are hungry and malnourished. Small-scale farmers are also produce the majority of the world's food. But less than half of these farmers use these diversification or resource-conserving methods. So there is actually room for improvement where it is needed most. Also, this argument that alternative forms of agriculture just cannot compete with industrial agriculture comes up over and over again and needs to be addressed. So we wanted to ask, is there a yield gap between diversified agriculture and conventional agriculture, or is this just a perceived difference? And to ask this question, we focused on organic agriculture, which is the most widely practiced alternative to conventional. Organic agriculture is defined as having no synthetic inputs, but farmers may or may not practice the full suite of diversification practices characterizing these more sustainable agriculture. So the environmentally friendly, no harm to nature is a bit of a tongue-in-cheek because some organic agriculture is really just conventional agriculture where all of the external inputs are coming from organic sources. But on the other end of the spectrum, we have organic farms that are truly using the full suite of diversification practices. However, organic agriculture in general has been shown to have better performance than conventional in some but not all sustainability metrics, including on-farm biodiversity, soil fertility, energy use, and efficiency. So we wanted to ask, is there really a difference between the yields of organic and conventional systems generally? And also, how do diversification practices influence the performance of these systems? So we conducted a meta-analysis, and we did so by collecting all the published and unpublished studies comparing organic and conventional yields that we could find. From those studies, we extracted a ratio of the yield of conventional and organic agriculture. We ended up finding 115 studies, and from which we extracted 1,071 yield comparisons, which represented data from 38 countries, 52 crop species, and 35 years. We then took all of this data and used a meta-analytic model to analyze this data. And from that, we were able to get an estimate of the average difference in yields between organic and conventional agriculture. So the x-axis is the ratio of the two yields. So 1 means that the yields are the same. The red area is the area where conventional outperforms organic, and the green is where organic outperforms conventional. And overall, with all this data, we found that a mean ratio of the organic and conventional yields with 95% credible intervals, which are an estimate of uncertainty. And we found this falls around 0.81, which means that organic yields are 19% plus or minus 4 lower than conventional yields. This is kind of the overall difference between all the studies we found and all the crop species. We wanted to ask, okay, but what about the diversification practices? So particularly, let's start with spatial diversification. And to do this, we wanted to compare a system where both organic and conventional systems did not have polycultures, so that's the monoculture versus monoculture. When both conventional and organic systems had polyculture, so that's the polyculture versus polyculture, and where only organic systems had polycultures and conventional systems had monocultures. So this is where you could really see the effect of the diversification practice. If polycultures influence both systems, you would expect the yield ratio to be about the same as the overall yield estimate because the relative difference would remain constant. And what we found was indeed when you have a similar practice in both, so both monocultures or both polycultures, the overall yield difference is about the same as the overall. However, when you look at the system where only organic had polycultures, you see a decrease in the yield difference. And in fact, it is only about 9 plus or minus 4. So the organic yield has gained relative to the conventional yield when organic systems have polycultures. And it also suggests that in the system where both systems had polycultures, neither is gaining relative to the other. So polycultures are actually positively influencing both organic and conventional systems. We next wanted to look at temporal diversification and mainly crop rotations. So we have a very similar setup. We're looking at when both systems have no rotation, when both systems have similar rotations, and when organic has more rotations. So again, that's where you can really see the effect of the diversification practice. We see a very similar result. When both organic and conventional systems have the same techniques being implemented, either no rotations or similar rotations, you don't see them gaining relative to each other. So rotations are positively influencing both organic and conventional systems. However, when there are more rotations in the organic, the yield gap drops to about 8 plus or minus 5. So again, you're seeing the organic system gaining relative to the conventional system. We also looked at a special variety of temporal diversification, mainly cover cropping. And the idea of cover cropping is that during some time of the rotation, you're keeping the soil covered. You're often planting legumes, which will fix nitrogen and add nitrogen to the soil, and then you're incorporating that into the soil afterwards. And we have a very similar system. We have both systems having cover crops, neither system is having cover crops, and just organic having cover crops. And here we see that the yield gap drops to 6 plus or minus 3, so almost insignificant, to where the organic system and conventional system are yielding almost the same. Overall, we found that there is substantial evidence that spatial and temporal diversification increases yields, both in organic and conventional systems. And this shouldn't really be a surprise. There's a lot of historical evidence for this. For example, in the Corn Belt in the United States, a corn-soybean rotation has about 25% higher yields than what's called continuous corn. So this is a modern example, but there's also just many other examples around the world where these diversification techniques increase yields. There are some caveats to these estimates, however, and particularly with that overall yield difference estimate. Because with this yield difference, we're looking at studies across many years and particularly across many crop types. So we are literally comparing apples to oranges. And we know that different crop species perform very differently in these systems. And to give you an example of that, you can see this is a similar graph. So 1 means that organic is the same as conventional. You can see there's quite a few crops that overlap that 1-to-1 line. For example, tomatoes and apples, there's a lot of variability, as well as, I believe that's barley. Or oats. It's oats. Whereas there are quite a few crops that do very poorly in organic systems, and particularly a lot of cereal crops like wheat. Potatoes also do very poorly, which is another carbohydrate-rich crop. And this isn't terribly surprising, though, because we've spent so much research and development in refining these crops for conventional systems. And so this really just isn't a fair comparison generally. We're mixing all of these crops together. We know they perform differently in different systems. And we're also taking crops that have been refined for organic systems and growing them, refined for a conventional system and then growing them in organic. So in general, we really need more research and development in organic systems. And in fact, if you look at the USDA budget, only about 2% of the R&D budget goes to organic and 98% goes to conventional. We really need more research and development, particularly in breeding seeds for organic systems. We also need more money going to understanding how we might be able to better mechanize these diverse agriculture systems. For example, how to better mechanize polycultures. And in general, we need to refine these diversification techniques for different crops, soils, and climates to give farmers better guidelines on what might work in their area and their system. So in general, we did find that there was a difference in the yields of organic and conventional agriculture. but that yield difference can be minimized when diversification practices are utilized. And to read it again, agricultural yields in and of themselves are not sufficient to ensure a sustainable food system without addressing the issues of distribution, diet, and food waste. However, we believe it is time to invest in analytically rigorous agricultural and socioeconomic research oriented at eliminating yield gaps between sustainable and conventional agriculture when they occur, and also identifying barriers to adoption of these techniques to improve the livelihoods of smallholder farmers and people generally around the world. And with that, thank you all for listening, and I appreciate your involvement. Thank you.